Welcome to a new playlist. In this playlist, we're going to be doing something a bit different, but is pretty critical for all CS students. And it's good to know anybody who gets into programming, working with computers, to know kind of just how stuff works lower level down to the bits, to the ones and zeros. And this is a good uh, e- I wouldn't say exercise, but project slash course to teach yourself. It's free. It's actually what my assembly language class teaches, and it's pretty common for everybody. But it's called Nanta Tetris, and what it does is it teaches you to go from a simple NAND gate. A NAND gate is it's a logic circuit, but here I'm just pulling it up here. Um, so a NAND gate is just a logic circuit that takes in two variables and it, uh, it spits out an answer. So we'll explain that further, but um, it's good to kind of understand how computers are basically built from the ground up, and this course slash project actually teaches you to build a computer from Boolean logic all the way to an operating system. So we're going to get started, and the first thing we're going to do is actually build some logic gates, um, which are basically like they're simulated chips is what we're doing. Like we're building computer chips, but like they're simulated in this hardware simulator. So to get started on this playlist, you're going to need the software. So just come to nantettetris.org/software. Download whatever you have, follow the instructions, and then we are going to dive into the projects. So if you don't understand like Boolean logic, that's something that we're going to be using a lot of in this, but I'll try to explain it as much as I can um, throughout it. It'll also have a bunch of kind of foreign sort of circuits and diagrams and stuff like that that you may not know if you just took like say programming um, in higher level languages like web development classes or something like that. Like this is more for like software engineering and like nitty gritty kind of stuff, not really like web based software kind of deal. But it's probably like the best, I guess, language to know if you want to get into like engineering, computer engineering, and like I guess like hacking if you want to uh, if you want to use it for that. But yeah, it's like this is the interface between software and the hardware. So between the electrical impulses that allow you to post a Snapchat all the way down to the chips, the ones and zeros and that sort of stuff. This is what controls it, and this is what it's all made of. So, um, but so yeah, download the software and the first thing, yeah, so download the software and we're gonna start going over the project. So project one, we're gonna be building all these gates. So all these chips, they're virtual chips. All these chips, not and or these are all like Boolean elementary Boolean functions. Um, I'm not sure if that's correct, but they're Boolean gates. Um, just taking a double check on that because I think I actually don't even need a book on this. I think they have it here. So this is the book that it's based on, but I think they have some lecture. Yeah, so Boolean logic. So yeah, they are Boolean functions. So we're going to be building all these chips, and if you've taken discrete mathematics or anything like that, this should be pretty familiar. but these are truth tables. It's basically saying you have a variable x, you're putting in a 0, it's returning a 1. So we're going to build the NOT gate for this video, and then we'll build the other ones in another video. But to keep this short, this will be kind of like an introductory one. So if you follow the installation, you're going to be able to launch. I'm on a Mac. It's, I think, just point and click for a Windows, but you can launch your hardware simulator. We're going to be using the hardware simulator. I'll just go to the Nanta Tetris folder. So we have all the projects in here. We have all the tools. So we have an assembler, we have a hardware simulator, CPU emulator, all this stuff. But for now, we're going to be working with the hardware simulator, building all these chips for project 1. So project 1 is we're going to be building this. We're going to start with the NOT. So we have 3 NOT files right here. One is a test file, one is a HDL file, and one is a comparison file, I believe. I'm not sure about that. I should probably do some reading on all this. I'm kind of just going off of memory from when I did it in school. But we are going to, not that, we are going to open this with a text editor. Okay, so yeah, so we're going to be editing these chips. So they give you a template, as you can see on all these chips. Those are comparison files. Actually, that's something I should probably just run through here. So a comparison file, it's giving you just a sample output. So at the end, after building the chips and running the test on the hardware simulator, we are going to get an output, and it's going to compare it to this just to make sure we got everything right. So we're going to start very simple, and it'll make a lot more sense. But for all these HDL files, you're going to have just a place here where you're going to put in your code. So the obvious thing to point out is that this site is called Nanta Tetris. So they actually give you the first elementary gate, which is a NAND gate. A NAND gate takes in 2 variables, and it outputs 1. So if they don't equal the same, so if you have 1 and 1 and you put it into a not and, which is what it stands for, then it's going to enter a 0, because it's asking not and. So 1 and 1 means and. So if it was a 1 and 0, it would equal 1. But yeah, this isn't how you program it, but they give you the first NAND gate, and it's pretty simple to understand while programming these HDL files and these chips, is that you're pretty much just making a function and passing in a variable. So it says here a NOT gate means out equals not in. So we have 2 variables here. We're going to declare A equals in and B equals in, and out equals out. I'll show you what this means when we test it. But just as you see here, like this NAND chip takes in 3 arguments. One of them is an in, and an out. So we're getting 2 inputs, 1 output. Now we're going to save this, and then we're going to go back to our hardware simulator, and we're going to load a chip. So we're loading our NOT, and you see we have our code in here. And then we're going to load a script. This is our test script. So not.tst. So this is a test file that is is using our chip to see if it passes the test and matches up with the compare file. So it's going to set in equals 0, evaluate, it's going to push it through and then give us our output. Then it's going to set in to 1 and then evaluate. So we should get um, this working fine. Like it's running through two instances. So we can, I think, okay. We're gonna run it like just in full. So end of script, it compared successfully. And as you see in here, we got an output, and it gave us the output of our chip running. And if you compare it, like it's comparing, so not out and not.cmp are the exact same. So I'll just quickly return to that. We're going to reset it, and we're going to just run it step by step. So it's loading the chip output file not.out, so it's creating that, it's comparing to that, and then output list in, I don't know what that means, but what I I don't know. I'll get back to you on that in the next video. But yeah, so it's setting into 0, input pin 0, and output is 1. Then it's set the input to 1 and the output is 0. So both of these are 0. That means it's not and, like 0, 0 and 0. Oh, fuck. Yeah, you need 1 and 1 for it to be. You need 1 and 1 for it to be an and 0 and 0 for it to be not and. So that ends up being true and false. Sorry. It's been a while since I've done this crap. But yeah, so that works out, and we see that the not out matches up with the not compare, and we've successfully built our first elementary logic gate, which is the not chip. And yeah, just poke around in this project file. You can see like these. This is how people are writing test scripts to test these chips. It's not too bad at this point, but we're going to be getting to building like more serious chips from our elementary ones like and or. Then we're going to build like a demux. We're going to build a XOR, a mux 8-way 16-bit multiplexer. Yeah, I remember this stuff. These are big ones. But yeah, have a look around and hopefully you'll enjoy this playlist. Thanks for watching.